and you should see a little thing pop up in your window that says I'm recording. That's how you can tell if I'm recording or not. And we will start. We're going to be talking today about kind of like the basic idea and the building blocks of programming, and in particular Ruby. And the first thing I want to do is that I'd like you to define these words in your notebook. I'm going to post this in your Slack channel once I get to your Slack. And in your notebook, let's take 5 minutes to define each of these terms, kind of warm up, refresh yourself about the stuff you've learned. As you finish that up, in your Slack channel, I posted a screenshot. For each of the terms that you've just defined, identify examples of those terms in the snippets below. We'll take about 3 more minutes. Let's give about 1 more minute. Cool. So that was a warm up, and we generally like to start our classes with a warm up, much in the same way that when you exercise, you kind of want to start with a warm up to get the blood flowing. And now we want to do this to get your mind working in a certain way. And so the class is called Methods and Return Values, and you should be seeing my whiteboard. Thumbs up if you see that. Cool. And we want to start defining some words. And the first one we're going to do is a method. Oof. And a method is a group of related instructions that achieve a purpose. I have to get used to writing more slowly with this tablet. I need to remember that it does not like, I'm a fast writer, and this is not conducive to that. But like, sure, like these are words. Method, that's a word I know. Group, instructions, these are all words I've heard before. But let's kind of put that into practice. Okay, you should all see my terminal right now. Yes? Is the text big enough? A little bigger?
Maybe move up a little bit, maybe with it.
How's
Perfect.
that? That's great. Awesome. So during Mod 0, have you worked with Pry at all? Yes, a little bit. Yeah, a little bit. That's fine. No. Pry is this tool that opens up a thing that lets us interact with Ruby in a way that's interactive. And to install Pry on your computer, you would just do a gem install Pry. It says like, hey, software on my computer, I want you to go find the gem called Pry and I want you to install it. This is not going to do anything because it's going to see that I already have Pry on my computer. So it's like, cool, I got everything Pry, it's already installed, whatever, I am happy. So we start Pry in our command line by typing in Pry, and we hit enter and we see a prompt such as this. And what we're going to do is that I'm just going to type in some Ruby code in here and see what it does. And I'm going to do hello world dot upcase. And what we're doing here is that upcase is a method. Upcase is a group of related instructions. And what it's going to do is that it's going to take whatever code that it is called upon, in this case here, the string hello world, and it is going to convert them all to uppercase letters. Right. And the idea here is that like upcase stands for, it is a kind of abstraction that lets us combine a whole bunch of code that's been written previously and use that here. Like when you think about it, like, well, let's say if you didn't have upcase, how do you think that you might want to do the same kind of thing? Like take a second to think about how you'd kind of replicate that. That functionality. Like you'd have to write essentially some code that's going to go through every single letter of this individually and then convert it and figure out like, hey, this is an upcase letter. Like we have the H, right? Is H capitalized in this case? Yes, so we don't do anything to it. Okay, cool. Then we move to the E. Is E capitalized? No, it's not. Let's capitalize that and save that, right? And we can see it here. There's a lot of steps, but someone has done that already and they've packaged it into this method called upcase. I kind of like compare it to like when, you know, the car companies make a new car. Like, do they have to start like, hey, all right, we need something round that will roll. Let us invent the wheel again. Like, no, we don't need to invent the wheel again. We all, at this point, have a fairly good understanding like how wheels work. We don't have to reinvent for a standard car like the internal combustion engine. We have these ideas how it works, and we reuse these ideas. We kind of build upon the work that's already been done. And this kind of exemplifies like one of the biggest things in programming is that we use methods in order to reuse code. Instead of rewriting all those lines of codes to just upcase a string again, we just used upcase method. And this is available throughout Ruby And the idea is that if we want to go ahead and like do other things, there's all a bunch of things we do. We can go lean back on code that's already been written for us. Arike, you had a question?
Yes.
Mhm.
What is the difference between an enumerable and a method? Because I
An
feel like
enumerable is a kind of method.
it is a kind of method.
Mhm.
Okay,
Yep.
thank you.
And we'll get into enumerables in greater detail later on. Cool.
Thank you.
Yeah, no problem. So we've seen here that we have this method upcase, but we also want to show that like this dot here means that we are running a method on an object. And that's another kind of important thing here. Methods run on objects. With this example, the upcase method is running on hello world, which is a string object. A good way to think about it is that methods are kind of like messages to an object. When we do this hello world dot upcase, we're saying, hey, this string here, give me yourself but upcased. And then it returns the upcase value we see here, hello world. The important key things here are that we use methods to reuse code. Upcase is something, a bit of code that Ruby has already given for us throughout your your mod 0 stuff. You've probably gone and used methods that are built in, but also going forward, you're going to be creating your own methods. And the second important point of this is that methods run on objects. Questions to this point about methods? You have until I finish sipping my drink. Roberto.
So does upcase permanently change that object, or is it only a temporary change?
It doesn't change anything at all. It's the term we want to use that it's non-destructive. It doesn't change whatever the contents are. It just returns. It gives us back the changed contents. The original stays the same, forever. I think we'll get into a little bit when we talk about variables. Sean?
Yeah, do you ever come across a situation where you're making a method, but it's already a method that was made in Ruby? Does that conflict with this too?
It doesn't conflict because usually, well, we're going to talk about this a little later on when it comes to scope, but you can make a method that has the same name. Upcase, it does something different. Like there's an order of precedence that it does things in. A lot of times I've made methods that do something very similar that was already built into Ruby because I just didn't know it existed in Ruby. And that's perfectly okay. Usually I'll do it and then someone's like, oh, there's a thing for that. I'm like, well, okay, I guess I'll have, like, it depends on how lazy I'm feeling. If it's a project I don't really care about, I'm like, whatever. If it's something I'm taking a little more seriously, I'll go back in, I'll change it to use the Ruby built-in method instead.
Thank you.
Yep. Luke?
You mentioned how upcase was a non-destructive method. Are methods always non-destructive?
They are both.
Cool.
I mean, both meaning there are some methods which are, and there are some methods which are not.
Yeah, absolutely. Cool.
Sean, is that a new question or same question? Nope. Okay, cool. All right. So, we have methods, and the second step here is that methods also have return values. And the return value is the output of a method. Things to know about return values. Like we said, a return value is the output of a method. A method has one and only one return value. And a return value can be either any type, right? It can be an integer such as 27. It could be a string, hello world. It can be a Boolean, true, false. If you need the return value to be a number of things, we could stack them into a data type such as an array, which contains multiple things. They could be in hash, it could be whatever. So if we come back to our terminal session here, we see here that we've called upcase on the hello world object. And we see here with the equal sign and the greater than symbol, that is the return value. The return value is the output of this upcase method, right? You are calling, again, you are calling the upcase method on the string hello world. The return value, which we can see is denoted by this equal greater than, is the in caps the string hello world. Any questions about return values? I'm gonna take another sip so you have time to formulate questions if you want. This is my hydration plan, making sure I drink plenty as you come up with questions. We all generally do not hydrate enough, I feel. Yes, Priya, get it, that liquid. Cool. All right, so the next thing we want to talk about is, let's go back to the whiteboard. Is it okay if I erase this? I want to talk about arguments. And they are the input to a method. Sometimes, so in this previous example, we've seen hello world, and we've called this upcase method on the hello world object, which is fine. That's like, sometimes that's all we do. But sometimes we want to give it more information. Arguments in general are the input to a method. And when you define a method, they are known as parameters. And a parameter is a generic placeholder for an argument. Didn't mean to do that, but you can get argument. 1T, not what I have there. Cool, let's go back to our terminal. All right, so we're gonna do this. We're gonna do this. Hello world dot include you'll also notice that I am not the greatest typist. So if I do make any misspellings, typos, please feel free to just unmute yourself and point that out before I get too far. So what's happening here is that we're taking that hello world string that we've worked on previously, and we're calling the include method onto it. And we are passing the argument hello to the include method, and the return value is true. And the include method says, like, essentially what the hello method does is that it checks the object, it looks at the object you call it on, and look at its argument. If whatever the contents of the argument are in the object it's called on, it will return true. If it does not, it will return false. So it's like, hey, one of the great things about Ruby that I enjoy about it so much is that Ruby is very English-like. I often say, like, Ruby is essentially bad English at times when it's written well. And so, like, not knowing much about Ruby, you could take a look at, like, hello world dot include hello true. I'm like, oh, that means that hello is inside hello world, and that's why it's returning true. If I do include pants, false. There are no pants in hello world. And I want to mention that parentheses are optional when we use arguments. I think that is a good habit to get into, using parentheses when using arguments because I feel that it makes it more clear exactly what's happening on and what exactly is an argument slash parameter. And you'll see that like the idea is that a big part of Turing is that not only do we teach you to write Ruby, we teach you to write in like this this standard way to do so, and like using parentheses for your arguments in this kind of pattern is standard. So we see that it hasn't changed a thing. Pants gives us false. Hello gives us true. Any questions about this include with the single argument so far? Cool. So that is a method taking a method that takes one argument. Some methods take no arguments, as we saw earlier with upcase. Upcase does have optional arguments, but like we don't have to send an argument in there. Include takes one. We can also use methods that take multiple arguments. For example, gsub is a method. It essentially stands for global substitute, and it says anytime whatever is in the first one, I'll find that and I'll replace it with the second. So instead of hello world, we're saying hello Taylor Swift. And we can, and to demonstrate this again, oops, no. We could take away these parentheses and it still works. Again, we still want you to generally use parentheses because I feel it's a little more explicit, and I prefer writing code that is more explicit. You want an important lesson to think about is like you are not just writing code for yourself at any time. You're writing code for the next person to write it, be it like someone else that takes on your project, or it could even be you 6 months from now. Philip?
Yes. So what is the parameter here? Is it hello, like for your dot include example?
Mm-hmm.
Is the parameter hello, and
yes,
hello is also the argument?
Yes. The arguments are the input, and when you define their uses parameters, often the two terms can be used rather interchangeably. Like if you use either term, I'll know what you're talking about. There's a little more nuance to it, but for this, like you could use, you can refer to it as either. Like you'll convey your meaning across. Cool. Where are we? Yeah, so you've shown that. Cool. Let us take a Pomodoro break. Let's be back at 1:35, and we're going to talk about variables. Resume recording. Cool. All right. I guess before we start in general, did anyone have any questions that just came to their minds while we were on break? Brett.
Yeah. So just as far as methods, the methods you use, I'm just keeping like little notes on them.
Yeah.
We just do that throughout. Cool.
I mean, you can usually for me, I never went out and learned methods. You can go to the Ruby documentation. There's a complete listing of all the methods and all that they do. I learned methods because I think that usually I'll want to do something and I'll just Google, how do I do this in Ruby? And usually someone's like, oh, use this, some answer, some blog post somewhere and says, oh, use this method. I'm like, oh, that's a method that exists. Alternatively, I will just, because Ruby is so English friendly, I'll go through the documentation. You have that, there's the list of all the methods there, and I'll look for one that sounds like the thing I want to do. Like include, that sounds like, if I want to see if well, if this isn't that, include sounds like a method that I would name it. So a lot of times just seeing the name oh, that sounds like a thing. Or capitalize sounds like is a method, and it capitalizes a string. And if you're looking to capitalize a string and you were scrolling through the documentation, you saw capitalize, hey, that might be the thing that I need to do my job.
Cool. Thank you.
Yeah, like most of them, I mainly learned about methods because I'm trying to do something and I don't know how, and I Googled it, and I'm like, there's a method for that. And it's usually when I want to do something pretty complex, that I will write my own method. Like I think that after a while, like you'll get an instinct. I'm like, no, like you're doing something. Like, no, there has to be a method for this. Like there have to be like 10 million people that had the same problem. This has to be a thing. So that is a thing. Cool. So the next big thing we want to talk about are variables. Variables are these keywords that we create to hold or point to return values that we want to maintain and reuse, right? So we have this string. You all can see my terminal, right? Yeah. Hello world. How many times have I typed in hello world already today? Like more than I want to.
Too many times.
Too many times, right? And so like we want to be able to use this over and over again. And let's say like we want the downcased version of this, like hello world downcase, and I wanted that downcase hello world. What we can do is we can set it to a variable. Greeting equals, and what it does is that it sets this local variable greeting to the downcase hello world. I think it's very important to note that when we're doing assignment in Ruby, this equal is known as an assignment operator, because what it's doing is like, hey, I'm assigning it to this variable. It will evaluate whatever is on the right side of that equal sign and then sets that to the local variable on the left. For those of us that grew up speaking English, that is a little counterintuitive because we are normally used to reading left to right. And it does take this like little kind of like, hey, wait a second, it's going to do everything on the right-hand side and then store that to the left. This is part of the order of operations, and like it's for this, he's like, oh yeah, it's just going to take the hello world downcase and shove it into greeting. I'm like, yeah, that's fair. This is a very simple example, but we got to think when things get more complex, especially if we're doing math with order of operations. PEMDAS, was it that? What do you call the thing that you mnemonic?
PEMDAS.
Yeah, PEMDAS.
Mnemonic is what's
Yeah.
called.
Please excuse my dear Aunt Sally.
Right, yeah. So we want to, like when we have in things where we have an order of operations, we got to remember that whatever is on the right will get evaluated there. And so we assign this variable, we assign the output of this to a variable so that we can use it later. And what we can do is that we can use it later by using this technique called string interpolation for strings here. And it looks like something like this. This is our greeting. Oop. And we have the pound symbol, also known as an octothorpe. And we close the string, and we see that in return values. It takes whatever the contents and puts that in the string. I want to note that this octothorpe and squiggly brace combination says like, hey, I don't want you to actually use greeting, like the string greeting. I want you to go get me whatever's stored inside that variable. Look for a variable called greeting and use that instead of like literal greeting. Any questions about variable assignment and interpolation at this point? Cool. I want to note that like when we use variables in this fashion, we define them and we can also reassign them. Right now, greeting is hello world. We could change it, our greeting, to anything we like. Like we are the owners of this variable. We decide what happens to it. We can change greeting to equal something else, to be good afternoon. And now greeting is good afternoon. However, like this is, as we use the term before, destructive. If we wanted to get the previous contents hello world, we can't. Greeting is just going to be good afternoon. You can't go back in time and then get the previous kind of answer back. It's like, what's a good real world analogy? It's like you throw something, you have a box, and you put something in your box, and then you throw away whatever it is and put something else in the box. Like you can't go back in time and get the last thing you kept in the box. That thing that's gone now doesn't exist. We've tossed that away. Questions now? Cool. All right. Now we're going to talk about defining our own methods. And let me kind of reconfigure my screen. Actually, let's make a directory for
What application has you using that grid?
it's called Divi. It helps me
Okay.
resize windows super quick. It's on the App Store. There are other. It costs something.
Oh, never mind.
I don't. There's another one called Spectacle, which is free.
Yeah, that's the one I'm on. All right.
I just like Divi better. Cool. Let's make a file. Code.rb. Cool. And let's make this bigger so we can all see. All right. So we've looked at 3 methods so far. We've looked at upcase, we looked at include, we looked at gsub, and these are all methods that are built in, and they're built into the string class. And the idea is that what if we want to build our own class with its own methods? So we're going to make a class that does some calculations, right? We're going to make this file code. Let's rename a calculator because we're making a calculator. And let's do this. Did I spell that right? Looks like I spelled that right. What? Of all the things I can't type, end is the one I can't type. Not calculator, but end. So we save this here. And we would run this by typing in the command line Ruby and the file name. What do you think will print out when I hit enter here? Just take 30 seconds to ponder what will print out. We've got some differences. We have some people thinking that it is welcome to calculator to print out. Some people saying nothing. And when I run it, nothing happens. The reason why nothing happens is that we didn't see the welcome message printed out because the class keyword here and the def keyword here, we've defined the class and method, but our code doesn't call the method, right? Remember that methods have to run on objects. So the first thing we need to do is we need to instantiate an object using our class. So we do that doing calculator equals calculator.new. And we're going to run the method we created on our class. So that is going to be calculator.print welcome. I'm going to save that and I run it again and it prints out to the screen, welcome to calculator. questions at this point about what we've done? Excellent. So we've made a method, cool, it does a thing, but we want to do more. Like we've talked about, the first thing we talked about when we started today is we talked about methods, and now we want to talk about arguments. What if we want to make a method of our own that takes arguments? Like that's fine. We can make one of the most basic things that calculus can do is add two numbers. So we're going to make a method called add. We're going to call it add. And we have that like so. And what we're going to do is that we are going to make a method called that, 1, 2. And when I run this, what do we, let's actually change this. Let's run this method. We want to run this add method that we created. So we'll take 30 seconds and predict what's going to happen when I run this, when I hit enter on my screen. That feels like 30 seconds. I'm very bad at time. Oops, forgot to save it. That's my thing. I always forget to save things. But it says wrong number of arguments given 0, expected 2. And because the thing is here, that add here says like, hey, we're defining that the add method is going to take 2 arguments, but it is going to, I don't actually give it 2 here. The one thing, someone told me this way to remember which side is which, given 0, expected 2, is that I'm throwing 0 things, so I have nothing here, but it's trying to catch 2, expected 2. So I have to go and we define our method to take 2 arguments, and we call it, we didn't provide it. So that's what that 0 and 1 is. So what we're going to do is that we're going to actually put the things, 1 and 3 are good numbers. They feel like good numbers to me. And cool. I'm going to run this. What do we think is going to happen now? Cool, got a range of answers, but let us put enter and nothing happens. Nothing happens is because, yeah, we're calling this method, we're passing 1 and 3 to it, but when we hit this add method here, like, you know, we're not doing anything in here. And so what we're gonna do is that we're just gonna put some code in here, num1, puts num2 in here. And we're going to go ahead and run the file again. And we see that, hey, 1 and 3. When we pass in arguments like so, the first thing we put in here is going to be assigned to the whatever's getting put in here. So num1 will become 1. And when we do use the variable here, num1 will have access to 1. And the second one here, this 3, num2 will map to this. So like the order that you send in arguments here is very important. They will take on the order that you put, that you order things in this manner. So we could actually do a 2 and a 4 here. And we save that, and we'll print to the screen 2 and 4. A good way to think of things is that an argument is a variable that's created at the start of the method. And you are able to use these variables here anywhere within the argument, only within this argument. I mean, only in this method and anywhere within this method. You don't have access to that outside. Why that is, we will talk a little bit more when we talk about scope. Questions at this point? So do we have a good calculator right now? I would call this the world's second worst calculator. Like it just gives us the things we put into it. It just gives us 2 numbers. I would say the worst calculator is if it gave you the wrong answer. This comes in like just a hair behind. That it just tells me what I give. Like that doesn't really help. So we want to actually do some math, and we want this to return something. We want this to give us some kind of return value, right? And so a return value is either explicitly defined using the return keyword, or it is the last line of code run, a code run if no return keyword is used. So what we can do is that we can get rid of this less cool stuff, and we can set sum equals num1 plus num2, and then we go ahead and return sum, right? That certainly adds. Or we could just say that, hey, this is going to be explicitly returned, and this. When we add those two things, that's the last line of code, and that gets explicitly returned. So when I run this, what am I going to, oh, Nell?
Oh, I was going to ask, I'm seeing that in the method definition, there's a space between the two arguments, but then you don't use the space when you call it. Does the syntax matter? Can it be different?
No. This will, if I do this, that'll still work.
Okay.
I like doing the space because visually for me, it gives me a little more eye space. I mentally have an easier time separating the two.
Yeah.
That's a very good question. I think that a lot of the stuff is very optional. Like, for example, you've seen that I've indented between the class here and the def and whatever's in the def. Like, I don't need to indent these things. I could do, it hurts my soul to do this, but I could do this. Oh, and that will still work. The reason why we have these indentations is that it gives us visual structure to our code so that we are able to more easily understand it. And I think it's very, very important that you get used to indenting correctly, because when you get errors, like when I write code, I make a habit, as soon as I define something, I'll immediately put an end on it, because if I don't immediately do it, I will forget. And then I'll get an error later on that says like, hey, you are missing an end. And then I have to go hunt for it. It's very important to like indent, because when we have like a missing end, looking at the structure, the literal shape of the code is also a very good debugging tool. Also, you'll piss people off if you don't use the proper indentation. Cool. I think it's very similarly to, it is like the code will work, but it's not pleasant to work with. For example, if I were to write a book that had no punctuation and just no spaces between words, yes, you can make sense of it, but would you want to read it? Would you want to work with it? Like, no. Like, this is kind of like this bit of developer empathy, and that we are writing code in a certain particular way in order to make the experience for whoever else works on this a little better.
Cool. That makes sense.
Yep.
Thanks.
Other questions? That is a very good question, pointing that out. All right. So, yeah, so we want to run this. What do we get? What do we think? We got a 6. We got a nothing. And we get a nothing. The reason why we have this nothing is that, yeah, we're calling this method and return to something. We're not doing anything with it. So in order to get this to work, we would need a puts here. And we run it, we get that 6. Dun, dun, dun. Cool. Nell? Did you have another question, or was that the hand up from earlier?
Oh, it's still up. Sorry.
Okay. Sean?
Yeah, how you put the puts outside of the class calculator, is that just preference? Why didn't you put it after the num1, num2?
Like in here? Yeah. Generally, you don't want to have, you want to kind of like, the idea here is that we want to split up the responsibilities of the code we write, right? This add method, like when we write methods should be responsible for one thing. So like I want the add method just to take the numbers and to add them up. The responsibility of like displaying that should be somewhere else. And that's why I put the puts outside.
Okay, thanks.
Right. I think a good example, a deeper example of why we want to do this is like, what if I needed to, we had some other use case for adding two numbers together, but I didn't want to print it onto the screen. I wanted to send that somewhere else, or I wanted to do whatever. I would have to write a whole nother method to kind of do that. And like this allows us to have a little more code reusability. Like, hey, let's display it to the screen when we want to. And if we don't have to, like, we want to like make our methods do very small things.
Okay, thank you.
John? Hand disappeared.
Oh, sorry. I jumped the gun. But before, for the num1 plus num2, you had it where it was sum equals and then return value. Is there a preference either or is there, what is good practice, I should say?
Yeah. I think there's various trains of thought on this. I think that this is one of those places where there is a valid opinion either way, right? This here, I feel that this here is very explicit. It's like, hey, I am taking one number, adding it to another number, I'm storing it in the sum local variable, and I'm returning it, right? It is very clear and very explicit what you're doing. However, I also think that it is clear that we are just adding two numbers together, and returning that, and whatever that is getting returning. I generally do not like to use the explicit return unless I have to, unless it is absolutely necessary to. Once you get into more complex things like with conditionals inside your methods, you may need to do an explicit return, but I would say that I would avoid using an explicit return unless you have to. I think that it cuts down on the line of code, the amount of code you have, and it makes it a little more cleaner.
That was the specific reason I asked, because throughout my studies, I saw some instances where return was shown and then you used it. So I thought, oh, maybe this is the time when I'm supposed to use it, but okay. So
yeah, there's no hard and fast rule. I would say, I think, and you'll hear me use this advice a lot of time, I think most people would not use it in explicit return. But when you get on the job, you will do what the rest of your teammates do. That's generally, when it comes to questions of style and opinion, you do what your team does. You don't want to be that person that comes in and just starts doing whatever. Like, that's just
Leroy Jenkins.
You just don't want to be that person, because like, you just don't. I'm trying to find another real world analog to that. I guess like you don't become a reporter in a newspaper and start writing a different language, I guess.
Okay.
Yeah.
Okay. Thank you.
Brett?
Yeah, so we have our two arguments, num1, num2.
Yeah.
And then where you do num1 plus num2, what do you call that area? Like the block, I guess?
Like this?
Yeah.
The thing is that, yes, block is a very vague term. The definition of block is just any lines of code. So like technically this is a block. Like this is a block. This is a block. There's also like a more narrow definition of block. When you're passing a block of code, you can pass like bits of code around, and that's when things get very confusing and very contextual. Like you really need to know what kind of context you're talking about to figure out what term of block, which block you're using essentially, which is, I hate that. I generally just call it like what's inside the method.
Okay.
Yeah, it's just like, the code inside the method. That's what I would call it. I would say like, I think that unfortunately programming is a field with a lot of jargon. And I don't like jargon for jargon's sake. I like to use I prefer to use technical precise terms. And I would much rather you tell me very specifically using plain English what you're referring to rather than some word that may have multiple definitions, such as block. Like, yes, using the term block would be correct, but like there are situations where it may not be clear what you're referring to.
Yeah, thanks.
Mm-hmm. Other things? Other things. Cool. Let's take another Pomodoro break. Oh, no, wait, that was brilliant. All right. Let's take another Pomodoro break. Let's be back at 2:07, and we will continue our journey.
Thank you, 207.
Let's resume recording. Any questions that came up from your Pomodoro over the Pomodoro break before we move on? Cool.
Sorry, Mike. This is Danny. This was kind of a weird analogy, but like when I look at that def and end, when I'm looking at def and end, it kind of reminds me of like a bookend, right? So like the def cover of the book and the end is the back of the book, and then everything in between is the information that's being given. Yeah.
And like I said, like whenever I define a method, def blah. Whoops. No, it doesn't work. Blah, immediately end, then I go up and type what I need to type. Because I've definitely, like spent absurd amount of times looking for a missing end because I just didn't do that. Like a little bit absent-minded in that manner. Cool. Anything else before we move on? All right. So the big picture is that like we have the basic idea of classes and methods, and like right now we are talking about the mechanics of like getting code to work. We are creating class, we're creating some methods. We haven't really discussed like really what object-oriented programming is yet, and we're gonna get into that. But one good thing to think about is like how to kind of read this code. And let's say you are looking at some code from somewhere else. Right, we have this kind of code, and you have some method. Like, where would you go to figure out what some method did? All right, let's pick someone from the rogues gallery. Christopher. Do you like Chris or Christopher?
I am happy with either.
Okay.
And
where would you go look for this? Where would you figure this out?
Into the class thing.
Right. And where would you find the class thing?
Well, if there's a specific file that is named thing.
Where would you? Yep, exactly. And like that's kind of like the idea here, is that if you see. If you're looking for this method, some method, like cool, that someone wrote, I'm like, all right, it's being called this object called this object thing, right? And we know that because every method we run needs to be called upon an object. And so all right, so where's thing defined? Well, thing is this thing.new. So I know that some method, this method, some method, is being called on an object belonging to the thing class. All right, cool. So if I want to figure out what the definition of this method is, I'll have to go to the thing class. And the thing class will generally be in a file called thing.rb. And this is the way we kind of structure our code. We structure our code in this way to make it easier for someone to figure out what we're doing. It is not like we would not want it. I would not, in my calculator.rb, I would not put class. Oh, what's the weirdest thing I can put in here? Astronaut, right? If someone's looking for an astronaut class, literally the last place they would look is a thing in the thing.rb file. I mean, calculator.rb file, right? This is why every class should have its own file name, and that file name should match the name of the class. This makes it easier for someone to find things. The big picture of this is to the big picture idea is called the principle of least surprise. You want to write your code in the least surprising way as possible. For example, I would not want to make a def subtract method that multiplied, right? No. Why would you do that? That is like a recipe for disaster. You want to write code that is as least surprising as possible. Programming is one of those places where we do not want surprises. Cool. Any questions about looking things up? Following this chain back? We are going to talk a little more in depth about how methods how to look themselves up, but for now, this is how this works. Cool. So the next step on our journey is that we want to call methods from other we can call methods from other methods. So what we can do is that let's make a method that will someone asked a question why do I put that puts here? I'm well, because I want to kind of separate the functionality of displaying it and actually separate the functionality of kind of adding the things together. So what I'm going to do is I'm going to make this method def print type. I have all this pressure to not make typos in front of you, but all this pressure of not making typos makes me do more typos, which is annoying. So what we can do is sum equals add first number, second number. And we're going to do puts the sum of first number and second number is sum. And I'm going to make sure that I've closed all my brackets. And I have all the closed quotes. That's another thing that'll get you. You will always open a squiggly bracket and forget to close it. I'm very guilty of that, and then everything breaks because of it. And what we're going to do is that I'm going to change this line of code to calculator dot print sum 2. All right. So when we run this in our terminal, it's going to look through. It's going to look through the code. Okay, cool. I have a class. It's got these 3 methods. I'm going to remember that. Cool. Doesn't do anything at this up to here because all it's doing is just reading and parsing and understanding what the code we have in here is. And then we get to line 16, and it's going to say, okay, all right. So I'm going to instantiate a new instance of a calculator, set it equal to lowercase c calculator local variable, and I'm going to run the method print sum, and I'm going to pass it in 1 and 2. Cool. So we go to print sum. Okay, 1. We have a variable called first number in here that gets set to 1. Second number that gets set to 2 because these happen in order. And what it's going to do is that I'm going to call the add method, which I've defined up here, and I'm going to pass that first number, which is 1, second number, which is 2, and that goes to here. It sets num1 equal to 1 and num2 equal to 2. It adds the 2 and then returns it back. The return value is, what's 1 plus 2? 3. And then sum gets set to 3. And that's what I kind of now we see why I talked a little bit briefly about how things get, when we're using the assignment operator, things get resolved right to left. It will run the add method, pass through the 2 values that's gone in here. The add method will do the things, they'll do all that math. It gives us the return value, and that return value gets set to sum. Now that we have that sum, we still have first number, second number, and we're going to put together the string using string interpolation to have the sum of first number, which is 1, And second number, which is 2, is the sum, this local variable here, which again is the return value of the add method when we pass those numbers through, and that should give us 3. And I'm going to try to run this and hope that I'm not making any typos or anything silly. And I see that the sum of 1 and 2 is 3. And I feel that I need a period there. Make it a little nicer. Leah?
Yeah, is there a reason why you named your parameters differently in the two methods, like num1 first number?
I generally do that to make sure that I don't get confused.
Okay.
Because like if I change this to num1 num2 and I say to you num1 num2, it's like which one am I referring to?
Gotcha.
Not very clear. You don't have to. It'll still work if I keep the same things, but I know like I think that like as you get through this, you'll come to an understanding of where things can get confusing, and you'll take steps ahead of time to prevent things from getting confusing, to prevent what's the word I'm looking for? What's the word where like what's the word where one thing can mean two different things? Not
Synonym?
not synonym.
Homonym?
Homonym?
Homonyms when things sound alike would mean two different things. Oh my gosh, I use this word all the time. It's oh man. We want to avoid ambiguosity. We want to have disambiguation. There we go. We want it so that when we're using words, when we're using variables, they're unique, and it is when I communicate with you, there's no question of what I am talking about. I want to be very specific and very explicit. Sometimes you're not going to be able to avoid that, but you want then in that case you take different steps to kind of avoid that kind of situation.
Okay.
We want to be as specific and as clear as possible, but it'll work.
Okay. Thank you.
Yep. Other questions? Cool. Oh, Angela?
So you typically hear in coding the dry concept, so like don't repeat yourself. Would that be repeating yourself just how many times we're writing the same two parameters like in your code?
Not really. When we say dry, that means when you essentially have two bits of code that essentially do the same thing, but live in different places. Like let's say I had a big application and here I have an add method, but somewhere else I also had an add method. Like no, we're having two different things of add. Let's just have it in one place and we'll call that one place. Right. That's what we kind of mean by we want to dry things up. Cool. Any other things you want to talk about before we kind of move on? So we've done a lot. We've written this kind of like this basic program, and we want to use these examples as kind of a lead-in to the 4 pillars of computer science. Dun, 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 whiteboard. Second. And the 4 pillars of computer science. Abstraction, inheritance.
What?
Polymorphism. And not the 4 pillars of computer science, the 4 pillars of object-oriented programming. abstraction, inheritance, polymorphism, and encapsulation. Like, these are 4 important things. We are mainly going to be talking about abstraction in terms of this. And this is, we're going to talk about like how abstraction lends itself to, how methods lend itself to abstraction, right? The advantage of using methods is that we can build methods that operate at higher levels of abstraction than other methods. To define abstraction, it's a practice where less complex functionality is exposed in the interface and more complex functionality suppressed. So this is like where higher level methods rely on lower level methods to take care of the details. For example, here we have this, we had this this add method, right? And what we leveraged, we created a rather more complex method, print sum. The print sum method is like, hey, this method is going to be responsible for taking 2 numbers, adding them, essentially adding them and displaying it to the screen. Like, no, like we don't need to have, the print sum method doesn't need to actually add them. Let's let the add method take care of that. We're just going to be responsible for printing things out. And kind of the real world example of this is that when we drive a car. Who here is very intimately well versed in the details of an internal combustion engine? No, like no one knows what it. Like that's ridiculous. Like, well, I mean, it's not ridiculous, but like I would not expect you to understand. Like, I would not expect every single person who owned a non-electric car to understand how an internal combustion engine works, how brake lines work. Even you know, it's like, I would say for most of you, you understand that when you have a car, you get in, you turn the key, you press the gas, it goes, you press the brake, it stops. Right? And and the car is just an abstraction of this. It's the same way it lets us kind of hide the details of what's happening. All we are concerned about, like for this calculator program, is that, hey, I give this method 2 numbers, it will print me out a nice message that gives me the 2 numbers added together. And we can see this is like when we start seeing electric cars, right? Electric cars, I would say, are like vastly different from, you know, the standard fossil fuel cars of the past. But here's the thing: do you need to learn how to drive an electric car? Like, if you've been driving a regular car your entire life, no. You still, well, the key's changing. Like, sometimes it's like just a thing you push in there now. But essentially, you have a wheel, you turn it right to go right, you turn it left to go left, you press on the gas to go. Well, maybe not the gas, but you press the left pedal. No, wait. Shit. You press the right pedal to go, you press the left pedal to stop. I literally just had to stick out my own legs and like figure out like which one's my left and right. But like that's what abstraction does. Like we don't, I guess like one way to think is like we don't care how the sausage is made. Like there could be something in the future, some new advance in math that changes how we add 2 numbers together. And we can change this add method that we've written in our calculator file to take advantage of that, whatever. But the thing is for the end user, it doesn't really matter. We still give it 2 arguments and it still gives us back the thing. And so we want to make it so that like the interfaces of these things remain the same, like the kind of the details and the mechanics are radically different. When we split things up, what we can do is that what we've done here in our code, let me go back and share. Nope, wrong one. Did I just break? Can you all see? Oh, wait. Can you hear me? Shit.
Yeah, we can hear you.
Okay. All right.
Yep.
My computer decided to eat itself for like 15 seconds. But can you see my desktop with my editor and my terminal?
Yes.
All right, cool. What we have here is that we've kind of abstracted away this adding method here. When like print sum is responsible for just printing out the information, collecting information. The add method is responsible for just adding to and returning the information. Essentially, abstraction, what we're doing with abstraction is that we are making sure that complexity is hidden away from the user. It's a little difficult to kind of really put this in perspective because we're not really doing complex things yet. Like essentially we are doing rather simple math. Like I don't think there's math simpler than adding two numbers together. But as we build in more complexity, I want you to think about like, okay, how do I split this up? How do I write reusable code? And when we have one method, call another method as an example of abstraction. Questions about abstraction. It is okay to have questions. It is okay to be like, we want to get this language to you early so that when you see it, it will make much more sense to you a little later on. So it is okay that.
Sorry.
Yep.
How would you abstract that addition piece? Like, how would you
This is already abstracted because what I'm doing here is that I'm calling this method I'm calling the add method and it's calling this method here. I'm not doing sum equals
num2. See. Okay, thank you. Got it.
Abstracting like, hey, this doesn't really belong here. I should pull that out this way. I think that Angela, was it you who said dry? We're asked about dry. This here is not dry, yeah. Right? Like this here, I'm like, I have this code here, which is exactly the same as this code here. So why don't I just I just call add like that. This dries out your code. I'm no longer repeating myself. I'm handing off and abstracting out the actual math to be added. Now, like what this does is that if I wanted to add additional functionality onto my computer, onto my method, and say here we have def root sum. Right. If I do this, I'm reusing this add method. Does that clear things up a bit more? Right. I don't have to reinvent the wheel. I know how to add. I did it the first time. Now, whatever code I write, we'll grab that and be very rude at the same time. Other questions at this point? Cool. Let's take a Pomodoro break. Let's be back at 2:35. And you'll have an exercise you'll be working on with your new best friend. And we'll wrap things up. And my next question, not my next question, is like my next thing is I want to ask you if you had any questions that you came up with during the Pomodoro break.
What is the name of your music playlist?
This is a curated class playlist. See, I start you off with the good stuff. Then then we start getting weird as you get to know me and you get used to me a little more. That's when I break out some more interesting choices.
I look forward to it. Thank you.
Yeah. All right. So let me stop my screen share if we have no other questions. The problem, the challenge of teaching and streaming online classes is that I have so many windows and I lose them all the time. And yes. Cool. So what I'm going to do is I'm going to put you into breakout groups, and in your Slack channel, I'm going to put out this if I can find your channel, just that you'll be working on. We work on this together. Again, it is important to note that this is not something you to rush through. Like if you don't finish it, that's fine. The idea here is to get you to really kind of understand what's happening. So I'm going to put you in the breakout rooms of hopefully 2 people a piece, or 2 to 3. 2 to 3 people a piece, and you'll be working on this until 250, where we're going to come back and talk about stuff. But here you go. Here we go.
Beautiful.